Now, it didn't happen in this problem. I was hoping it would. It didn't. When we found f, right, we needed to know two things, c and d, right? C and d. But we were given two pieces of information about f of 0 and f of pi that allowed us to get c and d. There's going to be an example or a problem within the homework where when you plug 0 in here, see how we plugged in 0 in here and all we had was d? There will be a problem in the homework where when you plug in, let's say that first thing in here, you're going to have c and d. I'm just going to give you an example. You'll have something like that. Let's say you'll get like that equation. You can't solve for c or d right now. I mean, you don't know what it is. But then you put in your other piece of information like this one, and you get another equation with c and d in it. And then you have to go back to college algebra and you have to solve a system of linear equations. You can use substitution or elimination to do that. Okay? You should, I'll do one of those next class. I don't want to do it today. I think I've done enough of those. What I recommend for your homework, I recommend you look at page 252. And I recommend that you do 1 through 14 and 17 through 34. This is just highly recommended for those of you, especially those of you going on to take Cal 2. There's no way you can do Cal 2 unless you've really mastered this section, because everything in this section is just very much assumed you can do easily. These antiderivatives that we've been doing today, like all this stuff, you know, antiderivative this should not require much thought, taking antiderivatives of that and things to powers. So good practice right here.
So when we start Cal 2, that's it. We're just going to start getting antiderivatives from the get-go.
It'll depend on your instructor. Oh yeah. Yes, but I'll restart this section. This is the section I'll start in. But I'll also introduce it in a different way because we need to know what we're going to be doing with this, and so we spend a little more time talking about what we're going to do. Okay, but get ahead. Okay, that's the thing. You don't want to say, well, you know, I'll wait till I start that and then I'll hit that real hard. The more you see now, the better off you're going to be later. All right, substitution. Does anyone remember what I told you to try and do when you do substitution? What it was that I was trying to get you to see? What you look for? Looking for something in its derivative, right? Looking for something in its derivative. Now there's two kind of schools of thought. I know we only have about, what, 10 more minutes? There's two schools of thought when it comes to this. I'm going to try something a little different. I'm actually going to give you a couple of problems here where I'm going to put the problem up there. I'm going to tell you what the substitution is, just so you can kind of see it. All right? I'm going to give it to you. So how about this one? How about finding the antiderivative of x cubed, and then in parentheses, 2 plus x to the fourth, then all of that to the fifth power dx. And I'm going to tell you that the substitution you should make is 2 plus x to the fourth. That's what I'm saying u is. All right, so I'm giving you all this. Now let's talk about why this substitution is the right way to go about this. I said try and look for something and its derivative. I also told you, or maybe I didn't say it clearly, but I'm pretty sure I told you it's okay to be off by a constant. Okay? So when we look at this, let's start looking for something in its derivative. How about x cubed? The derivative of x cubed is something x squared, right? 3x squared? Do you see x squared? Not right off. I mean, you could say x to the fourth is x squared, but it's not just like glaring, right, staring you in your face. All right, so let me try something else. X to the fourth. The derivative of x to the fourth is 4x cubed. Hey, here's an x cubed, right? That looks like x to the fourth would be a good candidate. Yeah, I'm off by a constant. That's going to be okay. But then I say, all right, before I just say I'm going to let it be x to the fourth, what if I grab the 2 also? What if I say 2 plus x to the fourth? What's the derivative of that? It's still 4x cubed. So what I'm going to try and do is grab something where I see its derivative is there, but I'm going to grab as much as I can without grabbing too much stuff. All right, so understand that? I'm going to grab this and this. The derivative of that is still 4x cubed. What if I try and grab this whole thing instead and call that my u? What's the derivative of that? Well, that's going to be chain rule, isn't it? I'm going to have 5, this to the fourth, times derivative. Do you see that there? Like if you take this out of here, right? Ignore this. Do you see the derivative of all that crap there? You don't, right? All you see is an x cubed. So that's too much stuff to grab. So this is the most natural candidate for the substitution. All right, understand? All right, so now that we have the u substitutions set, what we're going to do here is we're going to take the derivative on both sides of this with respect to x. So du dx is equal to, like you said, 4x cubed. And then we're going to play a little game here, all right? We will always, or at least I always, move the dx to the other side by just kind of multiplying both sides by the differential dx. That's still good? All right, so I'm going to come over to I brought different colors today because I wanted to kind of highlight what's going on here. This right here, right, that's my u, okay? That right there is my u. So I'm going to be able to replace that. And then the other piece I have an x cubed and the dx, right? And those are like being multiplied. So I could move the x cubed right there, put it right next to this. All right, and then over here, what I want in my du, somewhere over here, I want that x cubed dx. And we see it right here, right? X cubed dx. So I'm going to try on this equation to isolate that piece since it appears over there. So I'm going to divide both sides by 4. Or multiply by 1/4, however you want to look at it. Yes, I will. Okay, so up here, I have x cubed dx, right? In my equation, I do have an x cubed dx, but there's a 4 in front. So I don't want that 4 there. If it's going to match, if that's going to match that, I can't have the 4. So I multiply both sides by 1/4 here to give me 1/4 du here. On this side, x cubed dx, that's exactly what I have up there, right? All right, so let me rewrite this. This integral now becomes, I'm going to do the red part first. The red part is replaced with what? U, and it's still to the 5th power, right? So that's u to the 5th. And then this is multiplication. I can put the dot or not, but the blue part gets replaced with what? 1/4 du. So I'm going to put 1/4 du. Is that okay? Now 1/4 is a constant, isn't it? Okay, we can either leave the 1/4 in there and put it in front of the u to the 5th, like that. Or you can even bring the 1/4 completely out of the integral sign and carry it along in our answer. But we should be able to do it right here, right? This is just power rule, isn't it? Okay, what's the antiderivative of u to the 5th? 1/6 u to the 6th, right? And then the 1/4 is still out there. So 1/4 times 1/6 is 1/24. So this is 1/24 u to what power? U to the 6th plus some constant. But at the end of substitution, when you're done, you have to go back and replace u with what it was. So what was u?
Where did d go?
turned into the constant? Yes. If you want to look at it that way, I mean, technically it didn't, but if you want this piece and this piece, once you actually find the antiderivative, will vanish. All right? It's going to be gone. If you remember from last class, really, when I put this integral sign here, that's telling you, hey, go find an antiderivative for me, right? This right here was to let you know what the variable was. The variable here is u. So this is just notation to let you know what to do. You actually find the antiderivative is here. The plus c is technically because it could be this plus any number.
Last time you changed it from respect to x to respect to...
Yeah. All right, so now to get my final answer, the antiderivative of this, right? I'm coming back up here. The antiderivative of this should be equal to 1/24th u, which is 2 plus x to the 4th, in parentheses, to what power? To the 6th, and then plus c. And I said last time, the good news is you can always check your answer, as long as you can take a derivative. So if I ask you to take derivative of this, 1/24th sits out here because it's a constant. Something to a power is chain rule. So 6 drops out, what do you get? 6/24 is 1/4. And then it will be 2 plus x to the 4th to what power? 5th power. Chain rule. Now go inside, take derivative of this. 4x cubed. You get x cubed times this, which is that. See that?
Are you always going to be able to find a U substitution?
No. U substitution is our first go-to thing. Yeah. No. How about something like this? Secant squared of 1 over x squared dx. This will be our last example. I don't even know if we'll get through the whole thing. If you see it, don't say it yet. I'm going to give everyone an opportunity. All right, raise your hand if you think you know what the u should be. 1, 2, 3. Just 3, okay. What do you think? Arctan? No, I'm asking what u should be.
Oh, what you should be.
Yeah, tell me what u should be.
Squared.
X squared?
Or
And the derivative of x squared would be what?
1 with negative 1 over x.
Wait, you said x squared. Derivative of x squared is 2x.
Yeah, I'm looking at the 1 over x as the derivative of that one is 1 over x squared. Or no, that's kind of
What's the derivative of 1 over x? Negative 1 over x squared, right?
Yeah. That's what I saw. Yeah.
So do you all see that? It's there. Let me see. Let me rewrite it this way. Could I rewrite this problem? Is that not the same thing? It is, right? And if I look at it that way, then if I say u is 1 over x, I already know that du dx is negative 1 over x squared, right? Now you know that because I think I've told you a few times now, you should know what the derivative of 1 over x is without having to work it out. And the more you know, the better off you're going to be, as this problem illustrates. So at this point, I just say, all right, du is negative 1 over x squared dx. So I always just clear out that dx on both sides. And then I play my matching game. We're out of time. I'll let you finish this off because it's a homework problem. On page 306, what I'd recommend you start looking at is problems 1 through 6. And we'll just leave it at that for now. Those problems 1 through 6, they tell you what substitution to make. And then they let you take it the rest of the way.